This is a homework help video for Advanced Algebra Chapter 9, Lesson 2. We're going to look at 4 problems. Number 14 and 18 both ask you to find the LCMs, the least common multiple, of each set of polynomials. When you're asked to do that, say for number 14, I always start with the numerical, the coefficients, the 10 and the 35. What is the least common multiple of 10 and 35? So you can count by 10s, you can count by 35s, and you see what's the first number they have in common. 10, 20, 30, 40, 50, 60, 70 for 10s, 10, 35, 70 for 35. So the first number they have in common is 70. As far as the variables go, I make sure each variable is represented. And I see the letter S, and I see the variable T. And I pick the largest exponent for each of them. So S squared, 2 S's, the biggest exponent I see for S's, and T squared, biggest exponent I see for T. And I have found the LCM for number 14. For number 18, you have binomials that you're supposed to find the LCM of. Before you do anything, factor it, just like a 9-1. Factor it. Well, for the 4w minus 12, there's a GCF of 4. If I take that out, I have 4 times w minus 3. For the second binomial, there's a GCF of 2. Factor out a 2. And now what I'm looking for are common multiples of 4 and 2. Well, the least common multiple would be the number 4. And I also need to have every factor, every unique factor represented. And the only other unique factor is this quantity w minus 3. So 4 times the quantity w minus 3 is my least common multiple. Number 24, now we are adding. And when you add fractions or subtract fractions, you have to have a common denominator. That's why we talked about the LCMs. Well, right now, my common denominator isn't there. I cannot add 5 over r plus 7 the way it's written. So I have to think to myself, all right, there's 2 fractions. What would the common denominator be? Well, least common multiple of r and 1 is r. I need to write fractions that have r as the denominator. Now the first one's good. It's 5 over r. R's are set. The second one is not. I went from a denominator of a 1 to a denominator of an r. So what must I have done? I must have multiplied by r. 1 times r is r. If I multiply the denominator by r, I have to multiply the numerator by r. So my new numerator, the second fraction, is 7r. I do not want to change the value of any term in the problem. I just need to change the way it looks so I'm able to add them together. Now that my denominators are the same, in my answer, I have the same denominator, r. In my numerator, I add 5 plus 7r. Now, they're not like terms. I cannot get 12 out of that. It has to stay the expression 5 plus 7r. And now I have added those 2 fractions in number 24. Last one we're going to look at is number 32. It's adding, again. But now we're adding much more complex looking fractions. Before I do anything, I'm going to factor. Because I notice in the first denominator, m squared minus 4, that's a difference of 2 squares. In the second denominator, 3m plus 6, there's a GCF. So before I even think about adding, or think about common denominators, or LCMs, or anything, I'm going to rewrite the problem as factors. Difference of 2 squares. And the second one, GCF. Now why did I do that? Because I need to look at unique factors for my LCM, my least common multiple, which is my common denominator. For this particular instance, what's my common denominator? Well, my least common multiple, unique factors, and minus 2 is unique, so that's got to be part of my common denominator. M plus 2 is unique, so that has to be part of my common denominator. I really should write that in both. And what else is unique in the denominators? The 3. So I need to multiply by 3. I need to multiply this denominator by 3. Now I have my common denominators. I have to adjust my numerators accordingly. In this first one, the one on the right, I have a 3, I have an m plus 2. What I don't have in the problem that I have in my common denominator is this m plus 2. So I must have taken this denominator and multiplied it by m plus 2. So that means in my numerator, I have to multiply it by m plus 2. So my new numerator is 2 times m plus 2. If I look at the first denominator, I have m minus 2, m minus 2, m plus 2, m plus 2. So the only thing that's missing in my first denominator, the one on the left, is this 3. So I must multiply this denominator by 3, which means I multiply this numerator by 3. So my numerator in the fractions that I can actually combine and add will be 3m. Now, as far as the actual adding goes, we already know our denominator. Denominator is not going to change. It's going to be 3 times m minus 2 times m plus 2. Our numerators, we can add them together. Now, maybe your teacher says that you should simplify it, distribute the 2, and then add like terms. Okay, if we do that, we'll get 5m up top plus 4. Maybe you're supposed to simplify your denominator as well. If I start doing that, the 5m plus 4 is not going to change. My denominator is going to be 3 times the quantity m squared minus 4. I can distribute that 3 if need be and end up with 5m plus 4 over 3m squared minus 12. It all kind of depends how far your teacher wants you to go.